The next chapter that we deal with in physics is current and electricity. It is a very interesting chapter. In this chapter there will be a lot of circuits and there will be various methods in which you can use to solve those questions, and you have to choose the best method possible. So in the first question that we have been given a circuit. This is a cell of EMF E and there are resistances given as shown. We need to find out currents in each of the resistances, the wire AB, the wire CD and through the cell. So for solving this question, the best method here is that rather the first thing you should do in such type of questions is mark the voltage. Assume voltage at this point to be 0. So the voltage across the cell is always equal to E. Therefore the voltage at this point will be E. Now since this is a wire with no resistance, the voltage at this point will again be E. Now again this is a wire with no resistance, so the voltage at this point will be equal to the voltage at this point, that is again E. And the voltage at this point will be 0, this point is 0, again this point is 0. So now we know all the voltages at the various points. Now let us find out the current in each resistance. For a resistance we know that if this is a resistance, if the voltage at this point is V1 and the voltage at this point is V2, then the current flowing in this direction I can be written as V1 minus V2 upon R. If we would have assumed current in this direction, then we would have written it as V2 minus V1 upon R. Because in a resistance the current always flows from high potential to low potential. So using this logic, let us solve it over here. Let us look at resistance R1 first. For R1, the current will be in the right direction because this point is at higher voltage, and the current will be equal to E minus 0 upon R, that is equal to E upon R towards right. For R2, it will be E upon R towards left. For R3, it will be E minus 0 upon R towards right. Now we need to find out the current in the wire AB. So for finding out the current in the wire AB, what we do is that we analyze this junction, that is the junction at this point. Now the junction at this point, what is happening is that current E upon R is flowing towards right in this wire and current E upon R is flowing towards left in this wire. Let the current in this wire be equal to I. The current in this wire will be equal to the current across AB. Now by Kirchhoff current law we have the total current coming to a junction is equal to the total current leaving the junction. Therefore we get the total current coming to the junction is I. This is equal to E upon R plus E upon R, that is the total current leaving the junction, that is equal to 2 E upon R. So our answer for the part 2 comes out to be equal to 2 times E upon R. This can also be written as the statement of the Kirchhoff law, current law is like this: I1, I2, I3. Then we can write I1 plus I2 plus I3 equal to 0. That is the total current accumulating at the junction is equal to 0. Therefore we get the answer for the part 2. Now for finding out CD, what we do is that we analyze this junction. At this junction, E upon R current is coming from here and E upon R current is coming from here. So all this current, there is no other path, so all of this current will go into this wire. Therefore the current through the wire CD is 2 E upon R again towards right, and this was towards right again. Now to find out the current through the cell, what we can do is that we analyze this junction. So it is all about choosing the junction intelligently to find your answer fast. So at this junction, E upon R current is going this side and 2E upon R current is going this side. Therefore all this current must be coming from this wire, that is equal to 3E upon R, and this current is the same the current across this cell. Therefore the current through the cell comes out to be equal to 3E upon R. So our final answer for the current through each resistances are as follows, and the current through AB is 2E upon R towards right, the current through CD is 2E upon R towards right, and the current through the cell is 3E upon R towards left, that is from lower potential to higher potential. One thing to note over here is that in a load, that is a resistance is the load, current flows from higher potential to lower potential, that is in this direction. But in a source, the current flows from lower potential to higher potential, and thus we get our final answers.